this assessment, we're given a mass spectrum of hexane 3-ol and asked to rationalize the formation of 3 fragments and see if they show up in the mass spectrum. The question asks us or tells us that we're going to do 2 alpha fragmentations and 1 elimination, which is a common series of fragmentations that happen with alcohols. I'm going to try to color code this. So let's draw the first alpha cleavage here. If we do this, we can move this electron using that green arrow. That's going to give us a radical here that is not going to be detected by the spectrometer, and this carbocation. We can stabilize that carbocation by resonance. That's not what's really important here. What's important is that this has a 59 mass to charge ratio. And if we look around 59, you can see that we do in fact have a peak at 59. So we can point to that peak right there. Now it's tough for me to tell whether it's really pointing there, but you can see it's by 59 and there's a big peak there. If we look at the next alpha fragmentation, we can do it on the other side of the hydroxyl group. So now we'll use orange to do that movement there. That's going to give us, once again, a radical that is not detected by the spectrometer, and in this case, the 4-carbon carbocation. This carbocation can once again be stabilized by resonance. What matters to us is that it's going to show up with a mass to charge ratio of 73. And we can see if we look around 73, there is in fact a peak at that position. The last one we're going to do using blue is going to be a dehydration. So this is actually going to require 2 arrows, and it's going to be reminiscent of a mechanism we've seen before, but maybe not drawn exactly the same. Essentially, we're going to say that water is lost by the movement of that. That's going to give us the product water, which is neutral, which won't be detected in the mass spectrometer, and this alkene as the radical cation that will still be detected in the mass spectrometer. This radical cation, because we've lost water, should be 18 different than this 102, and so it's going to be at 84 mass to charge ratio. And if we look around 84, even though these peaks are tiny, you can in fact see that there's a peak around 84 mass to charge ratio. These are the 3 fragmentations, and we see that each of them shows up in differing degrees within the mass spectrum of the parent molecule.